Hi, let's do it. So, homework 9, we're going to go ahead and plot these points and see what we got here. So, I've got -5, +2. Let's just double check that. -5, +2, +4, +5, +4, +5. +6, -1, +6, -1. -3, -4. -3, -4. Okay. So we can kind of use a straight edge. It's not going to work because I, of course, need my hand to hold the camera, but I'm just going to use that as a guide. Okay. So it's looking pretty, you know, parallelogram-ish, rectangle-y maybe. So we should state a hypothesis here. If I had to classify this shape, I'm thinking it definitely doesn't look like a rhombus. These are not all equal sides. No rhombus, no square. So that's kind of my hypothesis. Is maybe these are parallel, so I got a parallelogram. Maybe that's a 90-degree angle, so it could also then be a rectangle. So let's do it. Let's calculate the midpoint of each diagonal. Okay, that's pretty awesome. Let's see here. So again, I like to come up with a hypothesis. I feel like the midpoint of the diagonal should be somewhere in there. I don't know exactly where. So let's see it. So, but the diagonal would be called DB, right? That's the diagonal. And this diagonal would be AC. So I'm going to list these points and these points. Now you might want to freeze the video and check to see if you can do this on your own and then just verify your answer. When we know from class, we should get the same answer, but we gotta just be sure. So we add the x values and we add the y values to find the number in the middle. So if we add -4 with -3 plus 4 and divide by 2, and then add the y values, -4 plus 5, divide by 2. I end up getting, that'd be 1/2. That would be 1/2. Let's check our thing for reasonableness. Okay, so that would be over 1/2, up 1/2, somewhere around in there. That's looking pretty close to my guess. Looks like maybe I was a little bit off. Okay, now let's confirm our hypothesis. We got, add the two x values. There they are, right? Add the two y values. 1/2, 1/2. Okay, discount, double check, triple check. Definitely 1/2, 1/2. Cool. So, let's calculate the slope and the length of each diagonal. So this diagonal and that diagonal. So again, slope would be rise over run. So slope of this line would be rise, run. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So I think the slope of DB is one of the diagonals, right? That's our first diagonal. I think I counted 9/7. So the slope is rise, run. Rows 9, ran 7. I'm going to verify that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Cool. Now I can confirm with the other formula. You subtract the y values, you subtract the x values. I can reconfirm that. So if I look at DB, all right, here's my D. Subtract the y values. So 5 minus a -4 which is the same thing as 5 plus 4. And then subtract the x value. So 4 minus a negative 3. 4 minus a negative 3, that'd be the same as 4 plus 3. Oops, I got 9 over 7 again. So I've discount double checked. That's our slope. Now our slope of AC, I think, should be downhill, right? I fell 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So AC slope, I fell 3. So I put negative 3. 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay, I can confirm that with my math. I subtract the two y values. So negative 1 minus 2, that's definitely negative 3. 6 minus a negative 5, that's definitely positive 11. So I've double checked that. Now the length. So that's interesting. I already calculated the slope, didn't I? I said that I rise 9, I run 7. So the slope, if I really did rise 9, run 7, the slope should be the square root of 9 squared plus 7 squared. And if I really did fall 3 and run 11, fall 3, run 11, this length should be the square root of 3 squared plus 11 squared. So technically, I can use the distance formula or this. So we'll do that. That'd be 81 plus 49. So this would be the square root of 130. Okay, and that would be 121 plus 9. Ooh, this is also the square root of 130. So it looks like I have enough evidence at this point. I'm thinking this is a rectangle. I'm going to write that in. Because I'm noticing that a regular parallelogram would not have diagonals that were equal. So the fact that those diagonals are equal are making me feel more and more like it could be a rectangle. But it could be a rhombus too, although it doesn't look like a rhombus at all. But okay, so let's get some more evidence to support our hypothesis. Calculate the slope and the length of each side. Okay, so that should be pretty easy. This slope and the length. So the slope of this, I fall 1, 2, 3, 4, 5, 6, 1, 2. So the slope of AD, I fall 6. So I got to put negative 6. I run 2. Let's look at B. I fall 6. I run 2. Oh, those are definitely parallel. So it's definitely a parallelogram. Fall 6, run 2, same thing. Now let's look at these positive slopes, right? The slope of AB, I rise 3. I run, let's count that off again. Rise 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Rise 3, run 9. Let's look at the slope of DC. I should put the M in front because that looks like the measure of DC, not the slope. This notation's really bad, so sorry about that. Rise 3. Run 9, same thing. Rise, run, 3 over 9. Interesting. So right now these don't look like opposite reciprocals, but if I reduce the fraction, so that could be a reason why we reduce the fraction, notice that these are opposite reciprocals. So these are same slopes, right? These are the same slopes. So opposite sides are parallel because they have the same slope. And these slopes here are opposite reciprocals. So that's confirmation that here, whoop, and that slope right there is the opposite reciprocal. That's why it looks like it's 90 degrees, because it actually is perpendicular. Perpendicular means it meets at a 90-degree angle. Two lines meet at a 90-degree angle. Okay. We're getting close to the finish line. So that was really confirmation that if those are all 90-degree angles because they're slopes. Sorry.
Report to the front circle.
Okay, those are opposite reciprocals. These are opposite reciprocals, so definitely 90-degree. I think we're ready to calculate this. So now that I know it's a rectangle, I know that, or a parallelogram, I confirmed it's a parallelogram as well. We know it's base times altitude. So the base is here, and since that's a 90-degree angle, we know that's an altitude. And so the base is really just the length of DC, which we already found. The length of that we didn't do that. I didn't do that. I found the length of these diagonals, but I didn't find the length of each side. So we got to go back and do that. So, okay, I'm going to draw this in here. So that's 6 and that's 2. So that length would have to be the square root of 6 squared plus 2 squared. And so would this length. Right? Square root of 6 squared plus 2 squared. This, we said when we found our slope, was 3 and 9. So this would have to be the square root of 3 squared plus 9 squared. And this would also have to be the square root of 3 squared plus 9 squared. Okay? So to find our length, which I never did, I guess I just took up my room here, the short length is the square root of 36 plus 4, so the square root of 40. And the longer length is the square root of 3 squared and 9, so that'd be 9 and 81, or the square root of 90. Okay, so those are our two lengths. If I multiply the base, which is the longer length, times the altitude, our shorter length, we should get all of this together. Okay, so let's see what that would be. 90 times 40, ooh, that's exciting. The square root of 3600 is 60. So that is so cool. The area of ours is 60 units square. Now let's see what our perimeter would be. So our long length is the square root of 90, and our short length is 40. And I have opposite sides are equal. So we add all that up. Now on the test, they might write it like this, clumping these two together, because I have 2 square roots of 90, and I also have 2 square roots of 40. They also might ask us to approximate that. So when I take the square root of 90, I get 9.5. So I have 2 9.5s. I take the square root of 40, I get 6.3. Parentheses 6.3. Okay, so I have 2 9.5s. It's about 19. And 2 6.3s, 12.6. So that is about, really just approximating here. There you go, units. Thanks for joining us.